So today I will explain why sin 90 minus theta is equals to cos theta, and later on we will try to understand what tan 90 minus theta is equals to. Okay, and similarly, once we understand all these things, we will be able to derive such identity for every other angle. Okay, so but before that, before I start to discuss all these things, I just want to take some time out and discuss about angles. Okay, my first question is, what is angle? So to understand angle, we can generalize it by saying that whenever we have two different line segments and if they intersect, then there is a possibility that we will have angles. Okay, for example, when this line and this line they intersect, there are several angles that has been formed here. Okay, I will show you. The first angle is this one. Okay, and the second angle we have is this one. Okay, and the third angle is this one. Okay, and the fourth angle is this one. Okay, but are these the only angles that has been formed here? No. Okay, why? Because we can arbitrarily have many different angles. For example, we can have angle from this point to that point, that is another angle. Okay, we can even have angle from this point to that point. Okay, and we can also have angles from this point to any other arbitrary point. Okay, to this point. Okay, so you can see, you can play around with this thing and you will always get different angles of different values. Okay, but my question is, like, how do we get the essence of what angles really are, and why are we limited to 360-degree? So let me try to explain what I mean by that. So let us suppose that we have this line segment. Okay, let us just consider this line segment, this green line segment, this x-axis, plus axis and minus x-axis. Okay, so if we are moving from plus x-axis to y-axis, so the angle that is formed here is 90-degree, correct? I hope it is clear. And if we move from plus x-axis and come back to this point again, so the total angle that we have is 360-degree. You can ask yourself, why does this happen? Why does the summation of all the angles sums up to 360-degree when we complete one revolution? So there can be various logic. The first and the one of the clear logic that we can think of is that you can assume that this is a circle. Okay, this is a circle, and oops, this is not a circle. You can assume that this is a circle. Let me draw it properly. Okay, let us assume that this is a circle, and if you move around this circle, let us suppose you start from this point. Okay, and upon moving you come back. Let us suppose you start and you came back to that point. Then it is said that the total number of angle that you would have traveled is 360-degree. Why? Because circle has an angle of 360-degree. You can look at it here. You can divide circle into 4 quadrants, right? You can divide circle into 4 quadrants, and each quadrant will have an angle of 90-degree, correct? So this angle has a 90-degree, this quadrant has a 90-degree angle, this has a 90, this has a 90, and this has a 90. Why I am saying this has a 90? Because this has 90-degree, correct? From there to this point we have 90, from there to that point we have 90, and from there to that point we have 90. So 90 times 4 is equals to 360-degree, correct? So that is one logic to look at this thing. Okay, so now let us get into the depth of this question that we are trying to address here, and we will try to see as in why we are getting this solution. Okay, so let us just draw arbitrary line from the origin. Okay, and let us suppose that this angle is theta. Okay, I have told you prior that the angle that x-axis plus x-axis forms with plus y-axis is 90-degree, correct? So just keep that in mind for a moment. Okay, now let us look at this part. So the angle that plus x-axis forms with this line segment L is theta. So what will be the remaining angle? Since the total angle is 90-degree, since that this angle is 90-degree, okay, since that angle is 90 degree and we have consumed theta, so what we will be left with? 90 minus theta, correct? I hope this makes sense to you. We have 90 minus theta here, okay? So since we have drawn a line segment here, let us mark it, okay? How? I will tell you. So this is the perpendicular. Perpendicular of what? Perpendicular of the triangle that we have formed here, okay? And this is the base, okay? Let base be denoted by B, and let us call this point, I don't know, let us say this point is Q. So we have triangle OLQ, okay, and we have the length of OQ as B, the length of QL as P, and the length of OL we will assume it to be H, which is the hypotenuse, okay, which is the hypotenuse. All right. So let us just call it H. Okay. Now let us just draw the symmetric sides. What I mean by that is I will draw another line segment on top of it as this part. Okay. I will draw it in dotted manner. Now you can see that this line segment, it is equivalent to that part. Okay. You can apply equilateral triangle and determine that. So its length will be B, and similarly this side, when we will map it on that side, its length will be P, correct? So its length will be P. All right. Now let us look at this part. Okay, let us look at this triangle OLQ. Let us look at this triangle OLQ, and for instance let me mark this point as R. Okay, let me mark this point as R. So we have two different triangle here. Okay, the first one is OLQ and the second one is ORL. All right, the angle, there are two different angles that we have to take care of. The first is theta and the second one is 90 minus theta. Okay, now we are looking at this triangle. Now we are looking at this triangle. So in this triangle, what is sine theta? When we look at sine theta, so sine theta is perpendicular. It is perpendicular upon hypotenuse, correct? Upon hypotenuse. All right. So in this case sine theta is perpendicular upon hypotenuse. Now what will happen if I try to find sine theta for this case, for this triangle, for the second triangle? So in that case 90 minus theta. Now let me just try to make it more clear, something here. 90, this is 90, okay, that is not 90. Let me write it properly. So this is 90 minus theta. Okay, so what is this? This is just a value, correct? 90 minus theta is some value of angle. Can I denote it with some other variable? Obviously we can, right? Let me just call it x. So from now on I will denote 90 minus theta, which is an angle, by simply calling it as x. Okay, so x is 90 minus theta. What is x? X is some value of angle. What is 90 minus theta? It is also some value of angle, and they both are equal. They both represent each other. Okay, so when I will say sine 90 minus theta, we can also say sine x. Okay, why? Because 90 minus theta and x both are identical. I am repeating this statement again and again so that you don't get confused. Okay, so now what will happen if I try to find the value of sine x? Sine x. Okay, now what is sine x? Sine x is nothing but sine 90 minus theta. Okay, now let us look at this triangle and let us find out what is the value of sine x or sine 90 minus theta. So we are in this part, right? So in this case, what will be its perpendicular? Its perpendicular will be this side, right, which is base. Okay, and its hypotenuse will be what? Its hypotenuse won't change, right? Its hypotenuse will remain as it is. Now when we are in this triangle, what will be the base of this triangle? If I am situated at this angle, the base will be this part, right, which is perpendicular, and its perpendicular will be base, right, this part. I hope you are getting what I am trying to say. So sine 90 minus theta or sin x is b by h. Now what is b by h? B by h is nothing but cos of theta, correct? Cos of theta, correct? So I hope you understand how I got this part, right? If you did not understand, let me clear it up with tan theta, so it will become much more clearer. Okay, let me erase it quickly, and then we will look at the other example of tan 90 minus theta, and we'll try to get a glimpse of what it actually means. Okay, so we have that. Okay, so this is the base for triangle OLQ. This is the base, this is the height. Okay, now why I am saying that this is the base? I am saying this is the base because the angle that I am considering is this angle. Okay, so this angle, it is lying on some base. Okay, and what is that base on which it is getting support? It is this part. Okay, so that is why I am saying that this is the base. Okay, now when we are looking at the upper angle, as in this part, so for this angle, what will be the base? For that angle, let me change the color. Yeah, so for this angle, what will be the base? We know one thing for certain, that hypotenuse is same. Okay, that hypotenuse is same. So for this angle, the base will be the side on which this angle is taking support, which is this side, right? And what will be the length of this side? The length of this side will be nothing but the length of that side itself, p, correct? Because it is in front of that, right? P. And if I try to construct this triangle like this, B is in front of that, so its length will be B. Okay, its length will be B. Now let me ask once again, what is the base for this theta? It is this part. What is the height? What is the perpendicular for this theta? It is P. What is the base for 90 minus theta? It is P. What is the height? It is the side which is in front of it, B, correct? Now I have initially I have told you that 90 minus theta, I have assumed it to be x. Why? One of the reason that I can give you is because x is very smaller. I mean x एक ही टर्म है, राइट? मेरे को यहाँ पे 90 minus theta में 2-3 टर्म लिखना पड़ रहा है. So it is a mathematician way to shortening the thing, right? I'm just simply denoting it. Okay, so now when I say tan of x, what does it mean? When I say tan of x, what does it mean? It means tan of 90 minus theta, and 90 minus theta, which is the angle, this angle, correct? This angle, है ना? This angle is 90 minus theta. Okay, all right. In general, what do we know about tan theta? That tan theta is perpendicular divided by base. All right. Now, what is the angle that we are looking at? We are looking at tan x, which is tan 90 minus theta, which is this angle. Okay. So for this angle, what will be the perpendicular? Perpendicular will be the side which is in front of it. ये वाला side. Okay. What is the value of that side? It is b, which is the base, correct? And perpendicular, tan theta होता है perpendicular upon base, correct? Let me write it inside. I mean inside में मैं इसे लिख देता हूँ यहाँ पे, ठीक है? And इस एंगल के लिए जब मैं देख रहा था, तो we had tan of x as base is equals to base upon whatever is the current base, right? I mean don't get confused there. Okay, so for this angle it is the perpendicular, b is the perpendicular and p is the base. Okay, बट ये थीटा वाले के लिए सी न लगता, इसके लिए पी था परपेंडिकुलर एंड बी था बेस. बट इसके लिए 90 माइनस थीटा के लिए वी हैव बी एज बेस, this part, b as perpendicular, sorry, and p as the base. Okay, now when we write b by p, what does it mean? It means cot of theta, correct? b by p is cot of theta, right? So we can get cot of theta here. Okay, great. So tan 90 minus theta, it will be cot theta. Okay, similarly you can solve for any other problem. In other problem the angle size might increase, you know, अभी यहाँ पे 90 के अंदर ही limited था. In some other problem your angle might even shoot up to this point, या you know यहाँ तक आ जाएगा वो, like 180 minus theta क्या होगा. So in that case you have to draw the triangle and you have to figure it out, you know, it will be easy. If you don't get it, so you can ask me, right? I will be there. I hope you understand everything that I have conveyed. Yep.